Since the dawn of our species, humanity has never stopped moving forward. First, we mastered fire. Today we play with the fabric of space and time. Technology is advancing beyond our wildest dreams. We may soon know the future and learn to move matter at the speed of light. Could mortals ever gain power over the entire universe? Will we become God? Space, time, life itself. The secrets of the cosmos lie before us, waiting to be discovered. Religious texts describe God as the master of all things in heaven and on earth, as the creator who guides the world we live in. But a total mastery of the universe may not be exclusively divine power. It could be humanity's destiny. Will we someday not only play God but actually become God? And what will we do with such omnipotence? Consider the games children play. A child playing cowboys might use a sneak attack as their trademark move. In the imaginary world they create, bullets can't harm them. They are invincible. They can do anything they want. Could these godlike powers one day become reality in the real world? UC Berkeley bioengineer Adam Arkin believes we are very close to achieving one divine ability, creating new forms of life. The evidence surrounds him in his laboratory. Organic-looking pieces of furniture fill the space, but these aren't made from traditional materials. They're formed from a fast-growing fungus. The artist Philip Ross calls this type of work mycotexture because the study of fungi is mycology, creating what he describes as the architecture of fungus. The artist crafted these stools by feeding wood chips to mushrooms. As the mushrooms consume their food, they grow fibers that interlock, forming a substance stronger than concrete. We are learning how to shape life to fit our needs, but the goal extends beyond this. The aim is to have living objects shape themselves according to our design. Just as religious texts describe God shaping Eve from Adam's rib, the aspiration in bioengineering is to program cells to self-organize into specific shapes or even more complicated, articulated forms. The dream involves creating living organisms that can sense their surroundings and change their shape on demand. Instead of a mushroom chair always remaining a chair, it would know when someone got tired and organically morph itself into a bed. To achieve this transformation, scientists need to learn how to control the movement of molecules inside living cells. Imagine a dancer as a molecule moving through space. Molecules make cells act. They bounce into each other. They bind. They pull. They stretch. And in doing so, make the cell perform amazing acrobatics, all of which can potentially be exploited for human needs. Every movement. A cell makes stems from instructions in its DNA code. Researchers have been subtly altering this code to change how molecules and cells are programmed to perform. As cellular engineers, scientists can now take DNA, engineer it, and put it back inside cells where it can direct cellular behavior. On a computer, programmers can design what they expect to see happen, convert that into DNA, insert it into cells, and then observe whether they follow the instructions. If researchers can control the behavior of one cell, imagine what becomes possible with many cells working together. Cells could be programmed to grow into whatever form is desired. A researcher could create an apple, a tree, or perhaps something never before seen in nature, like a living bicycle. In the case of something as complex as a bicycle, each part must work together: gears, wheels, steering mechanisms, and more. Each cell would need to be aware of its surroundings and work with other cells, each one different, each one with its own job. Part of the instruction set involves making that coordination happen seamlessly. This work could form the foundation for creating a modern Garden of Eden where humans, not a divine creator, decide what kind of life grows within it. Humans naturally want to feel in control of their world. We are animals that build things, control things, and change things. This drive appears to be part of who we are as a species. Religious texts describe God's ultimate creations as man and woman beings with their own free will. Humans have already crafted new life forms through genetic engineering and synthetic biology. But could our creations ever have conscious souls? Could we create entities with genuine awareness? Most scientists consider conscious experience to be an elusive property that may never be fully understood, much less artificially created. But neuroscientist Melanie Bali from the University of Wisconsin-Madison approaches consciousness differently. She doesn't view it as mysterious. In fact, she believes it can be quantified and expressed as a single number. The research attempts to quantify consciousness. By assigning a numerical value, scientists can measure how much understanding exists. How much consciousness exists in a system. One way to understand consciousness is to observe what happens when it fails or becomes impaired. Different brain injuries produce dramatically different consequences. Neurology teaches us that some brain lesions render a person unconscious while others don't affect consciousness at all. When damage occurs in the cerebral cortex, body organs like the heart and lungs may continue to function normally. However, a patient won't show any awareness of their environment. They exist in a vegetative state, alive but not conscious. But a person with injuries only to the cerebellum could still be perfectly awake and alert. Maintaining full consciousness. This finding is particularly interesting because the cerebellum contains many more neurons than the cortex. Despite having more neurons, the cerebellum doesn't play a vital role in consciousness. This tells us something profound about the nature of awareness. When comparing the cortex and the cerebellum, the difference isn't in the number of neurons. What makes the difference is the way different brain areas communicate with each other. The pattern of connections matters more than the raw number of cells. Imagine that each neuron throughout the brain is a light bulb. What would happen if every single one had its own independent switch? If you turned one light on, it wouldn't make any difference to the rest of the system. Each bulb would operate in isolation, creating random flashes with no coordination or meaning. The theory suggests that consciousness arises in the cortex because the neurons there aren't isolated components. They form an interconnected network that communicates constantly. If we had a set of lamps connected to each other, then turning one lamp on or off would make a significant difference to the rest of the system. In such a system, information is shared and integrated across the network. Now the lights are talking to each other. When one turns on, it signals another to turn off. When one turns off, it signals another to turn on, and so on in complex patterns. Together they create a dynamic symphony of electrical activity. Thoughts and emotions leading to the subjective feeling of being alive. This interconnectedness is thought to be essential for consciousness to arise in the brain. This understanding led researchers to develop a formula that allows us to measure consciousness mathematically. The formula calculates the degree of interconnectedness of neurons in any system. The answer is expressed as a number represented by the Greek letter phi. The more conscious something is, the greater its value of phi. The human brain, with trillions of neural connections forming elaborate networks, has a large value of phi. An earthworm's phi is exponentially smaller, but it's still not zero. The worm possesses some minimal level of consciousness. However primitive, one of the implications of this theory is that consciousness isn't necessarily exclusive to humans or even to biological systems. Phi could be used as a way to measure the level of consciousness in many different cases, whether in living beings or in computers. If researchers have found a way to measure consciousness mathematically, how long might it be before we design and build artificial systems that are genuinely just as religious traditions describe God populating Earth with sentient beings? According to religious texts, God solved the consciousness equation in one day, during creation, but there are other divine attributes beyond consciousness. One involves solving any problem, finding the optimal solution to any puzzle. One puzzle master believes any equation and any problem can be solved. If this is correct, divine wisdom could be within reach. Consider this problem. If you're a salesman or an actor and you have to travel to 15 cities around the world, what's the shortest route you could take to visit each city exactly once? The number of possible routes is staggering 87 billion different combinations. A divine intelligence would know the answer instantly, selecting the optimal path without hesitation. Mathematicians have wrestled with this type of logistical problem for centuries. These are called traveling salesman problems, and they belong to a class of computational challenges that become exponentially more difficult as the number of variables increases. If we could discover efficient methods to solve these problems, we would know the perfect way to do almost anything that involves optimization. Computer scientist Tom Ricicchi has pursued this type of divine wisdom throughout his career, at least when it comes to puzzles. He encountered the Rubik's Cube when he was in high school and found himself unable to solve it. It was the first puzzle that completely stumped him. Eventually, he realized he needed to keep systematic notes. He had to write down observations, like this move does this, and this move does that, building up a notebook that helped him figure out how to solve the cube. But merely solving the Rubik's Cube wasn't enough. The goal became conquering it entirely. Tom sought the underlying principle that would allow anyone to solve the cube in the fewest possible moves from any starting position, no matter how scrambled. Mathematicians call this optimal step-by-step solution God's algorithm. God's algorithm represents the ability to solve a random position as quickly and efficiently as possible. With infinite knowledge, you would always know what the next move should be to bring you closer to the solution. No wasted moves, no backtracking, just the perfect sequence of actions. In pursuing the secret to cracking this little puzzle, researchers may have stumbled across the method for cracking much bigger problems. These are challenges that have plagued humanity for centuries, from logistics and supply chains to medical treatments and resource allocation. Solving the Rubik's Cube won't by itself make the world a better place, but the mathematical methods used to find the quickest solution from any of the 43 quintillion starting positions might work for much larger, more important puzzles. Tom quickly realized that even an army of highly skilled Rubik's Cube solvers wouldn't suffice for finding solutions to every possible scrambled configuration. The fastest cube solvers in the world can solve the puzzle in about 10 seconds. If you took all 7 billion people on Earth and trained every single one of them to solve the cube that quickly, working 24 hours a day, 7 days a week, 365 days a year. It would take more than 1,000 years to explore all the different positions. Even the fastest hands and sharpest minds sometimes take wrong turns on their way to reaching the final arrangement. Tom needed unprecedented computational power. He needed a super brain far beyond human capability. The fascination with computers lies in their ability to expand what can be figured out. With computers, you can set up experiments and play with mathematics in ways impossible by hand. If someone can manually figure out that making one move, then another move changes the cube in a particular way, they hit limits. The sequences become too long to remember. Human working memory can only hold so much information. Computers excel at tasks that overwhelm human cognition. Even the most powerful single computer in the world isn't powerful enough to calculate God's algorithm for the Rubik's Cube through brute force. The problem space is simply too vast. So Tom decided to break up the cube challenge into smaller chunks, creating a divide-and-conquer strategy using a mathematical concept called group theory and cosets. Researchers figured out a way to partition the problem into 2 billion smaller problems. Each smaller problem could then be solved on separate computers, taking advantage of parallel processing. This approach distributed the computational load across many machines working simultaneously. Each computer in this network is like a separate processor, each trying to figure out the series of moves needed to get from a random scrambled position to another, less scrambled position. The computers worked through every possible configuration systematically, building a comprehensive map of the cube's state space. After approximately 1 billion seconds of computing time, roughly 35 years of computational effort compressed into a much shorter calendar period through discovered God's algorithm for the Rubik's Cube. The minimum number of moves needed to solve any configuration of the Rubik's Cube is 20 moves or fewer. Every single position of the Rubik's Cube can be solved in 20 moves or less, no matter how thoroughly scrambled it appears. There's always a 20-move sequence that returns the cube to its solved state. That's what a divine intelligence would do, always solve the cube in the minimum number of moves, with perfect efficiency and no wasted effort. Tom has cracked God's code for this particular puzzle. In the process, he has demonstrated that if a puzzle has a final solution, there's an optimal answer for each step along the way. The implications extend far beyond colored squares on a plastic toy. Could we solve any problem that has interconnected parts? Imagine being able to eradicate world hunger by optimizing food distribution to billions of people. The logistics involved are mind-bogglingly complex, involving agriculture, transportation, storage, political considerations, and economic factors. Or consider instantly curing diseases in the body by knowing the right sequence of medical procedures to target pathogens. If the right sequence exists, these methods suggest we might be able to find it. The ability to solve this seemingly simple problem demonstrates that computer power combined with clever mathematical ideas can take us much further than previously thought possible. There's genuine reason for optimism about solving other more difficult problems, reducing car accidents, alleviating poverty, addressing economic instability. There's tremendous opportunity waiting to be unlocked. However, God's algorithm only works for problems that have a definite, achievable solution. Real life isn't as simple as a brain teaser with a guaranteed solution. We can't always be certain which problems are actually solvable and which might be fundamentally intractable. How do we know which challenges to tackle with these methods? One scientist is using numbers and data to look into the future, to give mortals guidance about what can be predicted and controlled. Imagine if you could look at someone and instantly know everything about them, where they were born, where they currently live, and what will happen to them in the future. A divine intelligence could do this effortlessly. And in this age of digital data collection, humans are getting closer to achieving this power. Will we become omniscient? Richard Janikowski is a statistics professor at the University of Memphis. He isn't divine, but sometimes his predictive abilities seem almost supernatural. In demonstrations, he can greet someone by name and tell them remarkably specific things. He might predict that their analysis shows they'll want to spend about $7.10 on lunch. One of the first things they'll order is a salad. They've always been a fan of beets, so they should have some beets with their meal. Since payday was yesterday, they can treat themselves to some pumpkin pie for dessert. And the prediction includes that either they or one of their children will spill something during the meal. So extra napkins would be wise. People are understandably shocked by these eerily accurate predictions. How could anyone know such specific details? Richard's uncanny predictions don't come from divine insight or psychic powers. They come from collecting vast quantities of data and then finding patterns hidden in the numbers. If you're attempting to predict what customers would order in a restaurant, you would begin by observing customer patterns. How many people visit? What hours of the day? Which days of the week? Then you can analyze what they order: coffee or tea, green beans or corn, chicken fried steak or fish. If you also collect data on individual demographics, age, gender, income level, family size, neighborhood. You can begin connecting that data to purchasing behavior. Patterns emerge from the noise. Young families ordered differently than elderly couples. People from certain neighborhoods show distinct preferences. Income levels correlate with menu choices. Richard's data pattern analysis can read the behavioral signatures of any restaurant patron with surprising accuracy, but his work extends to an even more important domain. He can use data to identify criminal behavior before it occurs, seeing danger and patterns that would be invisible to human observation alone. Richard's expertise inspired the Memphis chief of police to invite him to a crucial meeting with the city's top law enforcement officials. The police needed Richard to achieve something that seemed almost miraculous. The chief laid out the problem. Frankly, what we've been doing traditionally isn't working. Crime continues to rise despite our best efforts. Can we do something different? He looked at Richard and noted that he had done previous work with the Memphis Police Department. Could that work be expanded to address other types of crime more comprehensively? After discussing the possibilities, the answer was yes. Let's try it. But one critical requirement would be ongoing access to data. Law enforcement would need to share their information consistently and completely. In 2005, Richard joined a groundbreaking crime prediction center in Memphis. The program is called Blue Crush Crime Reduction, utilizing statistical history. Blue CRUSH takes in video surveillance from cameras distributed throughout the city and centralizes data gathered by numerous agencies. Police reports, arrest records, 911 calls, traffic patterns, weather data, local events. All of this information flows into a central system. At the heart of the operation lies a program designed by Richard to analyze all the incoming data. The program looks for patterns, correlations, and predictive indicators. The idea is revolutionary. Stop crime before it happens. Instead of simply responding to crimes after they occur, can law enforcement prevent crimes by predicting where and when they're most likely to happen? What the system integrates is both arrest data and incident data. It uses theories that have evolved from criminological research on offender behavior to look for certain types of patterns. The guiding principle is straightforward. The past is the best predictor of the future. Criminal behavior isn't random. It follows patterns that can be mathematically modeled and predicted. The data revealed that some types of crime concentrate in certain areas and at certain times with surprising regularity. Research shows that home burglaries tend to take place during business hours when most people are away at work. Businesses, on the other hand, usually suffer break-ins after hours when employees have gone home and buildings are empty. These patterns repeat consistently across different neighborhoods and cities. The guiding principle of predictive policing is straightforward. If you effectively deploy police resources in the right place, on the right day, at the right time, you can reduce crime. It's not about having more police officers, it's about having officers in the exact locations where crimes are about to occur. Out on the streets. Patrol officers in Memphis now work with Central Command to anticipate and stop crime before it starts. The system can predict where there will be a concentration of robberies. Research shows that burglars tend to operate in a donut-shaped pattern around their residences. They don't want to commit crimes too close to home because neighbors might recognize them, but they don't want to be too far away either because they don't know the territory as well. This creates a predictable geographic pattern. The data channeling through Blue CRUSH's predictive computers has made Memphis measurably safer. From 2006 to 2010, violent crimes fell by approximately 25%. Burglaries declined 5 times faster than the national average during the same period. These aren't marginal improvements. They represent thousands of crimes that never happened, thousands of victims who were never victimized. Today this methodology can predict hotspots of criminal activity throughout an entire city with remarkable accuracy. But what about predicting the behavior of a single individual? The explosion of social media, market trackers, and surveillance cameras are converting our lives into data points. Every purchase, every website visit, every social media post, every location check-in creates a digital trail. With enough computing power and sophisticated algorithms. Could predictive systems anticipate what any individual person will do tomorrow? Could that ability tempt governments or corporations down a dangerous path toward a world where surveillance becomes ubiquitous and privacy becomes obsolete? Technology could soon grant the ability to know what neighbors will do tomorrow. But we would need more than that to be truly godlike. We would need to be able to control the world with the power of thought alone. Religious texts describe God speaking reality into existence. God said, "Let there be light," and there was light. What if humans could use their minds to make things do whatever they wanted? Could we control the universe with our thoughts alone? Asterisk, we might soon achieve the power of mind over matter thanks to the work of Brazilian neurobiologist Miguel Nicolas at Duke University. For the past 2 decades, he has been discovering ways for the brain to control its surroundings using only thoughts, with no physical movement required. Miguel believes the brain's potential can be understood by examining his country's most beloved sport, soccer. Asterisk, on a soccer field, when players start passing the ball back and forth, when a team scores a goal, the result emerges from the interplay of many players, the neurons interacting with one another. Every goal is the product of numerous individual actions, combining into a coordinated whole. Asterisk, figuring out how neurons produce a behavior is like understanding how a team of soccer players scores a goal. One approach would be to track every single movement from each player separately, but there are thousands of separate movements leading to any goal. The complexity quickly becomes overwhelming. Asterisk, Miguel developed a simpler approach. If you're sitting in the nosebleed seats where you can barely see individual players and can't even see the ball, you still know when a goal has been scored. You can see when all the players end up near one goal, and half of them start celebrating. The collective behavior tells the story. Asterisk, when neurons achieve a behavior, they also create electrical activity that can be detected, recorded, and even heard. Miguel calls these patterns brainstorms. The electrical signals of multiple neurons combine to produce a crackling sound that reflects when neurons start firing. It sounds like popcorn popping, each pop representing neural activity. Asterisk, by analyzing a brainstorm, Miguel can both hear and see neurons in the act of producing a behavior. The patterns are distinctive and reproducible. Different thoughts and actions create different brainstorm patterns. Miguel wondered if he could replicate one of these brainstorm patterns digitally, and in this way harness thoughts to directly control devices. Asterisk, Miguel set up a trial with rhesus monkeys. He first recorded the brainstorms of a monkey watching an avatar on a screen moving its arms. Interestingly, brainstorm patterns created by observing an action are similar to those arising from either performing that action or simply imagining it. The same neural circuits activate whether you do something, see it done, or think about doing it. Asterisk, Miguel digitized the monkey's brainstorm into a program that a computer could execute. The computer learned to recognize specific patterns of neural activity. Whenever the monkey even thought about moving the avatar's arms, the computer recognized the brainstorm pattern and interpreted the intention. Asterisk, the result was remarkable. Monkey CIST, computer do. The power of thought successfully moved the avatar on the screen. The monkey wasn't touching any controls. It wasn't moving its own arms. It was simply thinking about movement, and the avatar responded. Miguel's experiment points to a future where any person's wish instantly becomes a physical command. You could use your mind to control devices that are next to you or in a different part of the planet. The technology isn't even limited to Earth. There are aspirations of one day sitting on Earth and controlling a robot on the Moon or Mars just by thinking. The distance doesn't matter because we're not moving physical signals. We're detecting brain patterns and transmitting digital information. Asterisk, if it's possible for our brains to control objects with our thoughts, perhaps we can control the actions of living beings as well. What if we could see inside the minds of others and know their most intimate thoughts? This moves us closer to divine, omniscience. Asterisk, Miguel set up another groundbreaking experiment to explore brain-to-brain communication. He implanted brain activity monitors into a pair of rats. The rats hardly noticed the implants because brain tissue doesn't contain pain receptors. The sensors are very thin, hair-like filaments that can be implanted in the brain, like a pacemaker is implanted in the heart. Their purpose is to record neural signals. Asterisk, Miguel wired the rats so that neural activity the brainstorms could travel from one rat's brain to another rat's brain directly. He then placed the rats into individual cages in separate locations. In the cage of the first rat, one of two hatches either on the left or the right opens randomly. This first rat's job is to use its brain to encode that information. The rat sees which hatch opened. Asterisk, the brain activity recorded from this encoder rat is broadcast to a second animal in a different cage. In the cage of the second rat, both hatches open simultaneously. This decoder rat now faces a choice. It must select the hatch on the same side as the one that opened for the first rat. The decoder rat never saw which hatch opened in the first cage. Its only information comes from the neural signal transmitted from the first rat's brain. Asterisk, if the decoder rat gets it right and chooses the correct side, both rats receive a reward. Random chance would produce correct answers 50% of the time, just guessing left or right. But the results showed that the decoder rat got it right, approximately 70% of the time. The success rate significantly exceeded chance. Asterisk, the experiment wasn't perfect, but it demonstrated that information could flow from one brain to another. Thoughts were transmitted. One animal's knowledge became another animal's knowledge without any conventional communication. No sounds, no gestures, no physical cues, just direct brain-to-brain transfer of information. Asterisk, Miguel's research might lead to a future where thoughts can be shared as easily as words are spoken today. Imagine receiving feedback instantaneously from millions of people, being able to decide which thoughts to listen to, eventually collaborating through direct mental connection. We might, for the first time in our evolutionary history, directly influence our own evolution in ways we can consciously control. Evolution will continue to unfold in unpredictable ways regardless of our interventions, but we may gain unprecedented control over its direction. If linking our brains helps humanity achieve collective wisdom, and if our brains can be in many places at once through technology, what will happen to our physical bodies? Will they become optional? Religious traditions describe God as not only omniscient but also omnipresent. One scientist proposes the same potential for humanity, the ability to be anywhere and everywhere simultaneously. Believers in God report feeling divine presence no matter where they are. With billions of faithful people throughout the world, God must somehow be everywhere at the same time. Quantum physicists have discovered that tiny particles already possess this godlike ability to be in multiple places simultaneously. And since we are made of these subatomic particles, why can't we eventually be omnipresent like religious traditions describe God? Anton Zeilinger is a pioneer of quantum information theory. He studies the strange laws that govern how tiny particles communicate with one another. These laws are profoundly different from the classical physics that governs everyday objects. But every now and then, Anton likes to communicate with his peers using old-fashioned methods to illustrate the difference. In any communication, today, we primarily use classical methods. Take a letter being sent to a friend in China. The letter follows a defined path. It goes to the post office. The post office brings it to an airplane. The airplane flies to China, and so on. It's a well-defined trajectory that can be followed and tracked at every stage. When a letter goes through the mail, the information inside follows a physical trail from origin to destination. But in the quantum world, the rules are entirely different. In quantum communication, information disappears at one location and reappears at another place. It doesn't follow a path that can be tracked. You cannot follow it step by step. It simply ceases to exist in one place and begins existing in another. In the quantum world, information is carried by tiny particles in what scientists call quantum states. This state describes which features a particle can display if measured. You can think of particles like glowing balls of light that are constantly changing colors. If one is sealed in a box and you never open it, the particle exists in a superposition simultaneously in multiple states. It's both red and blue at the same time. However, when you open the box and observe the particle, it immediately takes on one specific color. The act of observation forces the particle to choose a definite state. Before observation, it exists in multiple states simultaneously. After observation, it exists in only one state. This is one of the fundamental mysteries of quantum mechanics. But the rules of quantum information become even stranger. If you take two boxes and two particles, you can connect them through a bizarre process called entanglement. This is one of the most counterintuitive phenomena in all of physics. Two entangled particles are connected in such a way that if you perform a measurement on one, it influences the state of the other one instantly, no matter how far apart they are. The distance could be meters or light. The connection persists. Anton realized that this strange property can be used to teleport information. Imagine Anton entangles glowing balls of light in two boxes. These two particles remain entangled no matter how far they're separated. So one box is sent far away to a distant friend. Anton keeps the other box locally. The boxers could be separated by miles, or thousands of miles. When Anton unseals his own box and observes his particle, suppose the light turns blue. At that exact instant, the distant, entangled partner becomes red. This correlation happens faster than light could travel between the two locations. It appears instantaneous. This is what researchers are doing with real particles, achieving something that seems like science fiction. Quantum teleportation. Information is being transmitted from one island in the Canary Islands to another in what appears to be a literal flash. The particles involved are photons, particles of light that can be precisely controlled and measured. The experiment works by maintaining one of the two entangled particles locally, while the other travels to a distant location. When measurements are performed on both particles, they demonstrate that they're still entangled despite the distance. The quantum connection persists across space. Having teleported information across short distances successfully. Anton's next goal is to achieve quantum teleportation between Earth and space using satellites. In the proposed satellite experiment, a satellite in orbit sends two entangled particles down to Earth, one to one location and one to another location. Measurements performed on these particles show that they remain entangled after their journey from space. Using quantum teleportation, we may be able to send and receive information to and from anywhere in the cosmos. The distance limitations that constrain conventional communication could be overcome. But could we teleport enough information to transport physical objects? perhaps even teleporting ourselves. Asterisk, there's nothing in the fundamental laws of quantum mechanics that says it would be impossible to teleport the state of a system as large as a living person. However, the practical challenges are enormous. It would require an unfathomable amount of information to be transmitted. Every particle in a human body would need its quantum state measured, transmitted, and reconstructed at the destination. Asterisk, it would take tremendous ingenuity across many generations to figure out how to accomplish this, if it can be done at all. The theoretical possibility exists, but the engineering challenges may be insurmountable with any foreseeable technology. Still, someday, in the far, far future, we may develop the power to be anywhere instantly through quantum teleportation. Asterisk, it appears that science may eventually give us both omniscience and omnipotence, godlike knowledge and godlike power. But are we fooling ourselves? Does humanity really have what it takes to become God in any meaningful sense? Science has granted us powers once thought exclusively divine. But will this progress come to an end? Asterisk, to become truly godlike, we would need to go back to the beginning of time and figure out how the cosmos itself was created. Can our mortal minds ever grasp the universal master plan? Can we understand the deepest laws that govern existence itself? Asterisk, physicist and philosopher Marcelo Glacier has spent his career contemplating whether humans have what it takes to become godlike, both mentally and physically. His approach to this question is unique. He participates in grueling obstacle races called Spartan races to explore human limits firsthand. The Spartan race is an obstacle course race. One particularly tough version is called the Beast. It ascends about 1 kilometer in elevation over 14.3 miles, featuring 25 obstacles, jumping over walls, climbing ropes, crawling under barbed wire through mud. Elite athletes can complete it in 4 hours. Most participants hope to finish in under 8 hours. Asterisk, Marcelo competes in these punishing races for one primary reason: to push his body to its absolute limits and discover what he's truly made of. The experience has taught him that no matter how hard anyone trains, humans can never reach the physical levels of a divine being. Our bodies impose limits on what we can and cannot do. Even the most accomplished athletes, even the most perfectly trained bodies, are never actually perfect. We all have limits. Asterisk, Marcelo believes that humans face not only physical limits that prevent us from becoming godlike, but also mental and conceptual limits. He sees evidence of these cognitive boundaries in the history of science itself. Physicists have been competing in their own cosmic race to understand the universe. Asterisk, it started with the ancient Greek philosopher Plato. Plato loved geometry and believed that to understand nature, you must find symmetry. Find the most fundamental symmetry that exists, and you unlock the secret of everything. This idea has dominated physics for thousands of years. Asterisk, most physicists still use Plato's idea of symmetry as a guiding principle to explain how the universe works. When one thing on one side is the same as on the other side, we call that symmetry. Looking around at the world, we see shapes everywhere in animals, butterflies, plants. There's a natural human drive to identify patterns in everything we see. Asterisk, our cognitive design pushes us to seek symmetry in the world. This tendency has led physicists to apply symmetry principles to one of the greatest mysteries of all: how the universe began. Many physicists believe that just before the Big Bang, the universe existed in a perfectly symmetric state, like a beautiful glass chandelier hanging in pristine condition. Asterisk, and then suddenly, everything shattered. The chandelier broke into billions of pieces. Scientists have been trying to put the pieces back together ever since, attempting to reconstruct what the original structure looked like. If we can understand how everything fits together, perhaps humanity can comprehend the fundamental nature of reality at the deepest level. Asterisk, but Marcelo proposes that physicists are trying to solve a puzzle that may not actually fit together the way we think it should. When scientists conduct experiments, they repeatedly find that symmetry breaks down. Nature doesn't actually follow perfect symmetry at the fundamental level. Asterisk, one of the most fascinating particles that exists in nature is the neutrino. These elusive particles barely interact with ordinary matter, making them extraordinarily difficult to detect. Most particles in nature spin. They have rotational motion. You would expect neutrinos, like everything else, to spin either clockwise or counterclockwise, displaying perfect symmetry between these two possible states. Asterisk, but nature doesn't work that way. It turns out that in nature, you only find left-handed neutrinos. They only spin in one particular direction. Nature apparently doesn't like right-handed neutrinos. Right-handed neutrinos either don't exist or are so rare that they've never been detected. There's a clear asymmetry at a very fundamental level of particle physics. Asterisk, this isn't the only example of nature's asymmetry. Even at the level of our own bodies, symmetry breaks down. Human hearts are positioned on the left side of the chest. Our livers are on the right side. These organs aren't positioned. If you took a human face, which might appear symmetric at first glance, and superimposed the left side with the right side digitally, the person would definitely not look symmetric at all. The two halves of our faces are noticeably different. Marcelo believes, the asymmetries found throughout nature tell us that our theories seeking perfect symmetry are fundamentally wrong. We're looking for something that doesn't actually exist. In fact, he suspects we will always be wrong in some sense. Finding one theory to explain everything may be a race with no finish line. Everything that we know about nature depends on how we observe nature, and it turns out that our observational tools are inherently limited. Since our tools are limited, what we can infer from nature is also limited. We cannot know everything. There will always be aspects of reality that lie beyond our ability to measure or comprehend. The quest for understanding is really about our human urge to comprehend a world that is never final and never perfect. This notion that there's always something else, that there's always an imbalance in the way we perceive things, is what makes us human. Our limitations define us as much as our capabilities. The human drive to become all-powerful and all-knowing seems unstoppable. Science has given us tremendous power over our environment and our own biology. We've split the atom, mapped the human genome, and sent machines to explore other planets. But we have limitations that we may never overcome. These limitations aren't necessarily weaknesses. Perhaps our fallibility is actually our greatest gift. After all, our limitations are what keep us striving to achieve what seems impossible. If we already possessed divine omniscience, what would motivate us to learn? If we already had omnipotence, what would drive us to innovate? The gap between what we are and what we aspire to become creates the creative tension that propels humanity forward. Consider the nature of scientific discovery itself. Every major breakthrough in human understanding has revealed not just answers, but new questions we didn't even know to ask. When Isaac Newton described gravity, he opened up entirely new mysteries about the nature of space and mass. When Albert Einstein refined our understanding with general relativity, he revealed even deeper puzzles about the fabric of space-time itself. When scientists discovered the structure of DNA, they thought they had found the blueprint of life. But that discovery led to questions about how genes are regulated, how proteins fold, how epigenetics influences heredity, how consciousness emerges from neurochemistry. Each answer generates multiple new questions. The physicist Werner Heisenberg discovered a fundamental principle that places limits on what we can know. His uncertainty principle states that we cannot simultaneously know both the exact position and exact momentum of a particle. The more precisely we measure one property, the less precisely we can know the other. This isn't a limitation of our measuring instruments. It's a fundamental feature of reality itself. This suggests that absolute knowledge of everything may be impossible even in principle, not just in practice. There may be aspects of the universe that are fundamentally unknowable, not because our technology is insufficient, but because complete knowledge is logically incompatible with the nature of existence itself. Kurt Gödel, one of the greatest logicians of the 20th century, proved something even more disturbing for those who seek absolute knowledge. His incompleteness theorems demonstrate that within any logical system, complex enough to describe arithmetic, there will always be true statements that cannot be proven within that system. No matter how comprehensive your axioms, there will always be truths that lie beyond reach. This suggests that no finite mind, no matter how powerful, can have complete knowledge of all mathematical truths. And since mathematics appears to be the language in which the laws of physics are written, this places fundamental limits on what any intelligence can know about the universe. Even our attempts to create artificial intelligence that surpasses human capabilities run into these same fundamental boundaries. We can create machines that process information faster than we can, that remember more than we can, that calculate with greater precision than we can. But can we create a machine that truly understands what it's doing? The philosopher John Searle proposed a thought experiment called the Chinese room to illustrate this problem. Imagine a person who doesn't speak Chinese locked in a room with an instruction manual. Chinese messages are passed into the room, and by following the instruction manual, the person can produce appropriate Chinese responses and pass them back out. To outside observers, it appears the room understands Chinese, but nothing inside the room actually understands Chinese. The person is just manipulating symbols according to rules. Searle argues that this is what computers do. They manipulate symbols according to rules, but they don't understand what those symbols mean. They lack genuine comprehension, genuine consciousness, genuine awareness. A computer can process the word pain without experiencing pain. It can analyze the concept of beauty without experiencing aesthetic appreciation. This raises profound questions about whether we could ever create truly conscious artificial intelligence. We can create increasingly sophisticated simulations of consciousness. We can create machines that behave as if they're conscious. But can we create the actual subjective experience of consciousness? Can we create genuine awareness? Most neuroscientists believe that consciousness somehow emerges from the physical processes in the brain. But we don't understand how. This is called the hard problem of consciousness. We can explain how brains process information, how neurons fire, how sensory data is integrated. But we cannot explain why processing information feels like something. We cannot explain the subjective quality of experience itself. The philosopher Thomas Nagel illustrated this with a famous essay titled "What is it like to be a bat?" Bats navigate using echolocation, perceiving the world through reflected sound waves. We can study bat neuroscience. We can measure their brain activity. We can create computer models of how their echolocation works. But we can never actually know what it's like to be a bat. We can never experience reality from a bat's perspective. Asterisk if we can't fully understand the consciousness of a bat. How can we claim to understand consciousness in general? How can we claim to create it artificially? How can we claim to be approaching godlike omniscience when we don't even understand our own minds? Asterisk, these aren't just philosophical puzzles. They have practical implications for the limits of human power. If we don't understand how consciousness works, we can't reliably predict human behavior. If we can't predict human behavior, we can't achieve the level of control and prediction that true omniscience would provide. Asterisk, even the most sophisticated predictive algorithms, based on data analysis, have fundamental limitations. They can identify correlations and patterns, but correlation is not causation. An algorithm might notice that ice cream sales and drowning deaths both increase in summer. A naive algorithm might conclude that ice cream causes drowning. Of course, the actual cause is warm weather, which leads to both more ice cream consumption and more swimming. Asterisk, this simple example illustrates a deeper problem. Data can show us patterns, but it cannot always reveal underlying causal mechanisms. And without understanding causation, prediction becomes unreliable. Unexpected events, black swans, can disrupt even the most sophisticated models because they arise from causes. The models didn't account for. The financial crisis of 2008 demonstrated this dramatically. The most sophisticated financial institutions in the world, using the most advanced predictive models and employing the smartest mathematicians and economists, failed to foresee the collapse. Their models were based on historical patterns, but the future introduced new factors their models hadn't accounted for. The models were sophisticated but not omniscient. Asterisk, consider also the weather. Meteorology has made tremendous progress. Weather forecasts are far more accurate than they were 50 years ago, but they're still not perfect, especially beyond a few days. This isn't just because our computers aren't powerful enough or our data isn't comprehensive enough. The atmosphere is a chaotic system, and chaos theory tells us that tiny differences in initial conditions can lead to dramatically different outcomes. Asterisk, this is the famous butterfly effect, the idea that a butterfly flapping its wings in Brazil could theoretically set off a chain of events leading to a tornado in Texas. In chaotic systems, perfect prediction would require perfect knowledge of initial conditions. But perfect knowledge is impossible because of quantum uncertainty and because measuring a system always slightly disturbs it. Asterisk, these aren't just technical limitations that better technology will overcome. They're fundamental features of reality that may permanently prevent any intelligence, human or artificial, from achieving true omniscience. Asterisk, what about omnipotence? What about unlimited power to shape reality according to our will? Here too, we face fundamental limits. The laws of physics constrain what's possible. You cannot travel faster than light. You cannot create or destroy matter or energy, only transform it. You cannot decrease the total entropy of a closed system. You cannot violate conservation laws. Asterisk, some of these limitations might be overcome with technologies we haven't yet imagined. Perhaps we'll discover how to manipulate spacetime itself to enable faster-than-light travel. Perhaps we'll learn to access energy from other dimensions or parallel universes. But other limitations appear truly fundamental. Asterisk, the second law of thermodynamics states that entropy disorder always increases in any closed system. This means the universe is gradually running down. Eventually, all stars will burn out. All matter will decay. The universe will reach a state of maximum entropy called heat death, where no energy is available to do work. Everything will be the same temperature. Nothing will happen anymore. Asterisk, this ultimate fate of the universe places an absolute limit on any civilization's power. No matter how advanced, you cannot prevent the heat death of the universe without violating fundamental physics. Even a civilization with godlike technology spanning the entire cosmos cannot escape the second law of thermodynamics. Asterisk, or consider the speed of light. Einstein showed that nothing can travel faster than light. This isn't a technological limitation. It's built into the structure of spacetime itself. As you approach the speed of light, time slows down for you and your mass increases toward infinity. To actually reach the speed of light would require infinite energy. Asterisk, this places limits on how quickly we can explore the universe, how quickly we can communicate across cosmic distances, how quickly we can respond to distant events. Even if we could somehow build starships approaching the speed of light, traveling to nearby stars would take years. Traveling to distant galaxies would take thousands or millions of years. Asterisk, the universe is unimaginably vast. The observable universe spans about 93 billion lights. There are an estimated 2 trillion galaxies, each containing hundreds of billions of stars. Even traveling at the speed of light, we could never reach most of this universe within any reasonable time frame. Most of the universe will forever remain beyond our reach. Asterisk, this presents a strange paradox for those who aspire to godlike power. A traditional conception of God includes being present everywhere simultaneously, able to act anywhere in the universe instantaneously. But the laws of physics appear to make this impossible for any physical being or civilization, no matter how advanced. Asterisk, we might send robotic probes to distant locations. We might establish colonies throughout our galaxy over millions of years. But we could never establish control over the entire universe. The distances are simply too vast, and the speed of light is simply too slow. Asterisk, there's another profound limitation on human power that emerges from our own nature. We are biological creatures shaped by evolution. Evolution didn't design us to be all-powerful or all. It designed us to survive and reproduce in the specific environment where our ancestors lived. Asterisks, our brains are remarkably powerful, but they're optimized for specific tasks. We're excellent at recognizing faces, interpreting social cues, understanding language, and making quick decisions with limited information. These abilities were crucial for survival in small hunter-gatherer groups. Asterisk, but our brains are not particularly good at understanding quantum mechanics, grasping the scale of cosmic time, thinking about probabilities accurately, or overcoming cognitive biases. These limitations are built into our neural architecture. Asterisk, we can extend our cognitive abilities using tools, mathematics, computers, scientific instruments, collaborative reasoning, but we're still working with brains that evolved for a very different purpose than understanding the fundamental nature of reality. Asterisk, some cognitive scientists argue that there may be aspects of reality that are simply beyond human comprehension, not because we lack sufficient intelligence, but because our minds are structured in ways that make certain concepts inaccessible. Just as a dog cannot understand calculus, no matter how much you try to teach it, there may be aspects of reality that no human mind can grasp. Asterisk, the philosopher Colin McGinn has argued for what he calls cognitive closure, the idea that just as bats are cognitively closed to the concept of prime numbers and monkeys are cognitively closed to the theory of relativity, humans may be cognitively closed to certain deep truths about consciousness, free will, or the ultimate nature of reality. Asterisk, this doesn't mean these questions have no answers. It means the answers may lie forever beyond human comprehension, encoded in a conceptual language our minds cannot process. If this is true, then absolute omniscience is impossible for beings with human-type minds. Asterisk, even if we could somehow transcend our biological limitations, perhaps by uploading our consciousness into computers or enhancing our brains with technology, we would still face limits. Any physical system has computational limits based on available matter and energy. Information processing requires physical resources. A brain, or computer, can only be so large and process information so quickly. Asterisk, the physicist Seth Lloyd has calculated the ultimate laptop, a computer with the maximum possible processing power allowed by the laws of physics. With 1 kilogram of matter confined to 1 liter of space, this ultimate laptop could perform about 10 to the power of 51 operations per second. That's an enormous number, but it's still finite. There are still problems it could not solve, questions it could not answer. Asterisk, no matter how advanced our technology becomes, we're still working within the constraints of physics. We're still made of matter and energy. We still exist in space-time. These fundamental facts place absolute limits on what's achievable. Asterisk, perhaps the most profound limitation is ethical, rather than physical or cognitive. Even if we could achieve godlike power, should we use it? The history of human civilization is filled with cautionary tales about the misuse of power. Every major technological advance has been used for both beneficial and destructive purposes. Nuclear physics gave us nuclear power plants and nuclear weapons. Genetic engineering gives us life-saving medicines and raises concerns about designer babies. Artificial intelligence gives us remarkable tools and raises concerns about autonomous weapons and surveillance states. Asterisk, the more powerful our technology becomes, the greater the potential for misuse. A civilization with godlike power would face godlike responsibilities. Who would decide how that power is used? What checks and balances would prevent its abuse? What happens when fallible humans wield infallible power? Asterisk, religious traditions that posit an all-powerful deity also typically posit that this deity is all good, perfectly wise, perfectly just. Divine omnipotence is tempered by divine benevolence. But humans are not perfectly benevolent. We're selfish, short-sighted, and prone to error. Giving humans unlimited power without unlimited wisdom seems like a recipe for disaster. Asterisk, there's also something paradoxical about the goal of becoming God. Religious conceptions of God typically include being eternal, existing outside of time, having no beginning and no end. But humans are temporal beings. We are born, we live, we die. Our civilizations rise and fall. Nothing we create lasts forever. Asterisk, even if human civilization survives for millions of years, spreading throughout the galaxy and achieving technological wonders beyond our current imagination, it will still be finite. The universe itself will eventually end. All our accomplishments will ultimately be erased. In the longest view, everything is temporary. Asterisk, this temporal limitation cuts to the heart of what it means to be God. A truly divine being exists outside the flow of time, unchanging and eternal. But we are change. We are processed. We are becoming. We can never step outside the river of time and view existence from eternity. Asterisk, perhaps the question, will we become God, is fundamentally misconceived. Perhaps it's based on a category error, like asking whether the color blue is heavier than the number 7. Humans and God, if God exists, are different kinds of things. One is temporal, physical, finite, fallible. The other is eternal, non-physical, infinite, infallible. Asterisk, we can become more powerful. We can become more knowledgeable. We can extend our abilities in remarkable ways. But becoming God isn't just about having greater power and knowledge. It's about being a fundamentally different kind of entity. And that transformation may simply be impossible. Asterisk, yet the pursuit of godlike abilities has driven human progress for millennia. The desire to understand our world, to control our environment, to overcome our limitations. This drive has led to agriculture, civilization, science, and technology. It has taken us from caves to cities, from ignorance to enlightenment, from helplessness to power. Asterisk, even if we can never achieve true omniscience and omnipotence, we can continue making progress. We can reduce suffering, we can extend lifespans, we can explore the cosmos, we can create beauty and meaning. We can build civilizations that embody our highest values. Asterisk, perhaps the goal shouldn't be to become God, but to become the best version of humanity we can be. To use our growing knowledge and power wisely, ethically, compassionately, to recognize both our capabilities and our limitations, to embrace our nature as finite beings in an infinite universe. Asterisk, the ancient Greeks had a concept called hubris, excessive pride or dangerous overconfidence. In Greek tragedies, hubris was the fatal flaw that led to the hero's downfall. Characters who believed they were equal to the gods, who challenged divine authority, inevitably faced nemesis divine retribution. Asterisk, there may be wisdom in this ancient warning. The aspiration to become God may itself be a form of hubris, a dangerous overestimation of human capabilities. By all means, we should pursue knowledge and power, but we should do so with humility, recognizing that there will always be mysteries we cannot solve, powers we cannot achieve, limits we cannot transcend. Asterisk, the physicist Richard Feynman once said that he could live with doubt and uncertainty. He said he didn't need to have answers to every question, that it was okay not to know. In fact, he found doubt and uncertainty more interesting than having false certainty. This attitude of epistemic humility might be more valuable than the quest for absolute knowledge. Asterisk, similarly, recognizing the limits of our power might be more important than attempting to achieve unlimited power. Every ethical system recognizes that power should be constrained. Unlimited power, as Lord Acton observed, corrupts absolutely. Perhaps our limitations aren't bugs, but features, built-in safeguards that prevent us from destroying ourselves. Asterisk, consider the story of King Midas, from Greek mythology. He was granted the power that everything he touched would turn to gold. At first, this seemed wonderful and limited wealth, but he quickly discovered the horror of his gift. His food turned to gold. His drink turned to gold. When he embraced his daughter, she turned to gold. The power he had wished for became a curse. Asterisk, this myth contains a warning about wishes granted without wisdom. Gaining the power to transmute matter sounds wonderful until you consider the consequences. Godlike powers without godlike wisdom would be catastrophic. Asterisk, we are already seeing this dynamic play out with technologies we've recently developed. Social media gives individuals the power to broadcast their thoughts to millions of people instantly. This is unprecedented communicative power, but it has also enabled the spread of misinformation, amplified polarization, and created new forms of harassment and manipulation. Asterisk's genetic engineering gives us unprecedented power to modify life itself, including human life. But we haven't yet developed the ethical frameworks to guide the use of this power. Should we eliminate genetic diseases? Most people would say yes. Should we enhance intelligence? Maybe. Should we create designer babies with specific traits? The answer becomes less clear. Asterisk, as our power grows, the ethical questions become more difficult and more urgent. We need wisdom to match our power, but wisdom has not advanced as rapidly as technology. This creates a dangerous asymmetry. Asterisk, perhaps the most important lesson is that becoming God shouldn't be the goal. The goal should be becoming fully human, which means recognizing both our extraordinary, capabilities, and our inherent limitations. It means using our knowledge and power responsibly. It means maintaining wonder and humility in the face of a universe far larger and more mysterious than ourselves. Asterisk, the cosmos has existed for nearly 14 billion years. It will exist for trillions of years more. Humans have existed for perhaps 300,000 years. Civilization for about 10,000 years. Modern science for about 400 years. We are infants in cosmic time, just beginning to understand our world. Asterisk, we have learned remarkable things. We have achieved remarkable feats. We have transformed our planet and begun venturing into space. But we are not gods. We are humans, curious, creative, fallible, mortal beings doing our best to understand a universe that may ultimately be beyond complete comprehension. Asterisk, and perhaps that's exactly as it should be. Perhaps the universe is richer, more interesting, more meaningful precisely because it contains mysteries we cannot fully solve, because it holds possibilities we cannot fully control, because it remains forever, partly beyond our grasp. Asterisk, the religious traditions that conceived of God didn't just imagine a being with ultimate power and knowledge. They imagined a being of ultimate goodness, ultimate love, ultimate purpose. If we truly aspired to be godlike, perhaps we should focus less on omniscience and omnipotence and more on wisdom, compassion, and meaning. Asterisk, we can create life, but can we cherish it? We can predict behavior, but can we understand suffering? We can control matter, but can we create justice? We can process information, but can we generate wisdom? We can build powerful technologies, but can we build good societies? Asterisk, these questions may be more important than whether we can split atoms or sequence genomes or build artificial intelligence. The measure of our civilization won't ultimately be our technological achievements but how we treat each other, how we steward our world, what values we embody, what legacy we leave. Asterisk, in the end, the quest to become God may be less important than the quest to become fully human, to develop not just our powers but our virtues, to cultivate not just knowledge but wisdom, to pursue not just capability but meaning, to recognize that we are part of something larger than ourselves, a universe of staggering complexity and beauty that we can study, appreciate, and participate in, even if we can never fully master it. Asterisk, the cosmos doesn't need us to be gods. It needs us to be conscious, compassionate, curious beings who use our remarkable but limited abilities to reduce suffering, create beauty, seek truth, and perhaps, just perhaps, help the universe become aware of itself through our eyes, our minds, our hearts. Asterisk, that may not be omnipotence or omniscience, but it might be enough. It might even be more valuable than divinity, because consciousness that knows its limits, power that exercises restraint, knowledge that embraces uncertainty, these might be more precious than absolute power and absolute knowledge. Asterisk, we are mortals in an immortal universe. We are finite beings contemplating infinity. We are temporary patterns of matter and energy that have somehow become aware, can ask questions, can seek understanding, can create meaning. That is miraculous enough. We don't need to become God. Being human, with all its limitations and possibilities, is extraordinary in itself.